Good day all. We'll be looking at another example under Armature reaction. Now our question says an 8-pole generator has an output of 200 ampere at 500 volts. Lap connected armature. We need to know this. Lap connected armature has 128 conductors, 160 commutator segments. If the brushes are advanced 4 segments from the no-load neutral axis, estimate the armature demagnetizing and cross-magnetizing ampere turns per pole. Okay, so we know that it is lap. So our A is therefore number of what? Poles, which is what? 8. We know this one. Okay. So to better understand the question, this is what is happening here. Normally, we are meant to, for us to get our demagnetizing formula, we have that AT is equal to, pi over 360 times Z I over A. Now, this was the formula for demagnetizing MMF. But in this case, we weren't given theta. Instead, we were told some things that could help us to get this ratio. This ratio of theta over what? 360. So, looking at your motor, is cross-sectional view. Let us say that our brush was tilted towards this angle, and this is our no load neutral axis, as previously mentioned in the question. This is our no load neutral axis, while this is our polar axis. Now, this is where our brush now finds itself, and we call this place our magnetically neutral axis. Now, initially, when we were solving with this formula, we had that the angle from here to here was what? Theta. Was theta. So the ratio of this theta, this angle, to the whole angle was what this ratio represented. This theta over 360, that is exactly what it represented. This angle over what? 360. But in this case, we weren't given an angle. Instead, we are told that our brush was advanced 4 segments. But our total segment was what? 160 commutator segments. So if the total segment is 160 and our brush is now advancing 4 segments, so we can actually derive another ratio without using this one. So we can still say it like this: in 360 degrees, which is the whole circle or the whole armature, we have what? 160 commutator segments. While in just that angle that we are interested in, this mechanical angle, can say is having what? Consisting of 4 segments, 4 commutator what? Segments. So if theta is equal to 4 and 360 is equal to 160 in this question, we can now replace this ratio. So that's what we'll be doing. So we'll be replacing this ratio with this 4 over what? 160. Remember, what we are trying to find is what? Armature what? The magnetizing ampere turns per pole. So this is for your A. So when we replace these two, we have it to be 4 over what? 160 times our Z being what? 128. Our Z is number of what? Conductors. We multiply it by our what? Current, which is what? 200. And divided by our A. And since this case we are talking about a lap connected, meaning that we are using what? Number of poles, which is what? 8. Now, solving with calculator, we have that our answer to be what? 800 ampere what? Turns. So this is for our demagnetizing what? Ampere turns. We have gotten that part. Now for the second one, which is our cross magnetizing what? Ampere turn. The formula will differ. Okay, I'm clearing the whole of this. Now for our B parts, we have that 8cc, which is a larger part of the armature reaction per pole, is equal to 1 over 2p minus theta over what? 360, all in brackets, z I over what? A. Now, like we said earlier, we'll be replacing this ratio with 4 over what? 160. So we have that 1 over 2, our number of poles is what? 8. Minus 4 over what? 160 for this question times, this I'm saying for this question is that 360 is not constant, like it's not equals to 160, it's not constant, it's not a constant thing. It's just for this question, question we are solving. So this is not a constant relationship, but this is constant, but this might vary. So for our number of conductors, 128 multiplied by your current, which is what? 200, all over what? A, which is what? In this case, 8. So with a calculator, so we have that our value is 1200 watts ampere turns for our what? ATC. And once again, we see that our ATC is larger than our what? ATD, which is our demagnetizing ampere turns per pole. Thank you and God bless you. Please subscribe to the channel. See you in the next video.